Okay, now let's look at the theory of the refrigeration cycle. So the first question is, in a refrigeration cycle, how many components? Obviously, you know, there are four major components, right? So let me draw this refrigeration cycle diagram. Okay, you will see we have a evaporator in the bottom here. Okay, evaporator, that's what's the cold air coming, right? You feel cold air coming from the evaporator. Okay, and downstream of the evaporator, it's a compressor. Okay, compressor. Then after that will be the condenser. Okay, then will be the expansion valve. Then come back to the evaporator. Okay, so these are the four major components. Okay, so two components has heat transfer, right? Obviously, in evaporator, you feel cold air, you feel cool, right? You have heat transfer. So the heat transfer is into the evaporator, right? Hot air going into evaporator, exchange for cool air. Okay. Then in the condenser, that heat transfer. This is heat transfer out. Condenser is a heat exchanger. It reduces the temperature of the hot refrigerant, right? The heat the condenser heat exchanger fluid receive heat, okay, from the refrigerant. So how about the compressor? They have work into the system, okay. Then expansion valve release the pressure. Okay, so these are the major components. Remember when we studied this in thermodynamics, we draw the TS diagram and the pH diagram, right? This is a simple TS diagram. Okay, so 1, 2, 3, 4. These are the four points, right? So look at this. This is the dome. Okay, inside the dome is two-phase mixture, right? Right side is vapor. The left side is the liquid, right? Okay, so let's look at the whole process. Starting from 2 to 3, before and after the evaporator. When the refrigerant fluid enter the evaporator, it is a two-phase mixture, right? Liquid vapor. And he receive heat in the evaporator from the environment. Then the phase change. Okay. When that phase change, temperature won't change. So from 2 to 3, 3 ideally it's on the dome, right? It's saturated vapor. Okay, receive heat, so change phase from mixture to the vapor. Then 3 to 4. 3 to 4 is from before and after the compressor. After you have compressed the refrigerant, you have received work. Obviously, the temperature rise. Okay, you get energy, right? Okay, so 4 is in the superheated vapor. After the compressor and before the condenser, it's superheated vapor. So after the condenser, then you have heat transfer. You remove heat from the refrigerant, then it becomes saturated liquid. Okay. Then what happened to the expansion valve from 1 to 2? Expansion valve, so that the phase change, then liquid become two-phase mixture. Okay, that's the whole refrigeration cycle process. So this is the TS diagram we just showed. You also remember we have a pH diagram, right? Pressure, enthalpy. Okay, so the pH diagram should look like this, right? Before the evaporator and after the evaporator from 2 to 3. Okay, phase change, your pressure doesn't change. Okay, 3 to 4, compressor, pressure increases, right? Again, on the condenser from 4 to 1, also phase change, pressure don't change. Okay, go through the expansion valve from 1 to 4, 1 to 2, then obviously pressure decreases, expanded, right? So this lab, the first lab of the refrigeration cycle, you are required to produce a pH diagram like this. So you have to measure the P pressure and enthalpy. So how do you get enthalpy? Okay, from your engineering table, right? You can measure the pressure and the temperature. So in the refrigeration cycle, refrigerant, you can find the H. Okay, so that's one of the tasks we're gonna do, okay, to produce pH diagram for the refrigeration cycle. So think about it, how many pressures you need to measure, how many temperatures you need to measure, okay? And you probably don't need to measure the pressure at all 4 locations, right? Because in this whole system, there's only, look at this, there's only 2 pressures, okay? So, and the temperature and pressure are used to find the enthalpy. And you don't need all the measurement points either for enthalpy, because look at from 1 to 2, for example. When you go through the expansion valve, what happened to the enthalpy? Okay, pressure decreases, but enthalpy doesn't change. Okay, straight line down. Okay, so that's one of the tasks for the first lab. The second task for the lab is for you to calculate the degree of superheat at the evaporator outlet. Evaporator outlet is at the 3, right? Number 3. Okay, here 3. So right now the drawing from here, 3 is on the dome, right, on the line. That's the ideal conditions. But in reality, when you do the measurement, the 3 is not exactly on the dome. It will be inside the vapor region. Okay, so compare the temperature on the dome and the temperature actually inside the heated vapor region. The 2 point, ideal point and the actual point, the temperature difference is so-called the degree of superheat. Okay, so after you produce the pH diagram, you will see the point 3, okay, the temperature on the point 3 comparing to the temperature, ideal temperature on the dome. Okay, that's the degree of superheat. Okay, so these are the 2 tasks for the first lab of the refrigeration cycle: to produce the pH diagram, as well as to calculate the degree of superheat at number 3, at the evaporator outlet. I'd like to introduce a little bit about the operation procedures. Although we will do the lab for you and shoot a video for you. The process should be like this, and there's a lot of valves on the entire refrigeration system. It's look like a complicated system. Okay, so these are the valves. Okay, so you have to set it up like this: open and close the valve as scheduled. Okay, as listed in this table. Okay, After that, you turn the refrigeration system on. Okay, push the start button. Okay, then when it runs for about 20 minutes, it will reach to a relatively stable condition, and you can start to read the pressure and the temperature data. Okay, I will show you how to read them in the video, in the actually experiment video. Okay, so you will have in the handout I posted on Moodle, you will have a blank pH diagram like this. Okay, like this. Okay, print it out and put your points 1, 2, 3, 4. Measure the point on this pH diagram and submit it with your report. Okay. Okay. I don't want you to create your own pH diagram. Just use this diagram and use a color pen to put your 4 points there. Okay. And then you will see the pH diagram. Then you will clearly see the superheat, degree of superheat at the evaporator outlet. Compare the point, actually measured point in the vapor region comparing to the ideal point on the line. Okay, so that's the degree of superheat. Okay, so that's the report requirement for lab 1.